Assalamu alaikum. Hi guys. Today we are going to have a brief intro of nodal analysis in this tutorial. Nodal analysis is one of the easiest and powerful method to analyze any sort of circuit, and it's a systematic and will give you the right answer if you follow the steps accurately. As an example, we are going to discuss this diagram and we are going to analyze this diagram. There are some steps to be followed to analyze and calculate the values of or to analyze and solve this circuit accurately. The first step is select a reference node. Reference node is also known as ground. That is this node. This is the symbol of that ground, and it is also known as a reference node because the voltage here is 0. And the other two nodes, the second step, that is assign node voltages to non-reference nodes. There are two other nodes that is known as V1 and V2 as pointed by right marker. These are known as non-reference node because they are not connected directly with the ground. There is always a branch between V1, V2 and ground. So here is the third step that says that apply KCL to each non-reference node. Now to apply KCL on each non-reference node, we have to draw the direction of current flowing, entering and leaving the node. Here on V1, the current 3 ampere is entering the node, and I1, I2 and 6 ampere is leaving the node V1. And on V2, current 6 ampere and I2 is entering the node, and I3 and I4 are leaving the node. So here is the complete stepwise procedure. We have to follow these steps step by step accurately to solve and analyze the circuit. Now we will apply KCL on each non-reference node. According to KCL, sum of all the currents entering the node is equal to sum of all the current leaving the node. By applying KCL at node V1, we have this equation that we will write the current entering the current that is entering the node on the left side of the equation, that is 3 ampere, and the current that is leaving the node on the right side of the equation, that is I1 plus I2 plus 6 ampere, that is leaving. Now by according to Ohm's law, we will represent all these branch currents in terms of voltages as I1 is from V1 minus 0 across this 5 ohm, that is I1 is equal to V1 minus 0 divided by 5, and I2 in terms of voltage will be V1 minus V2 divided by 2. Now we have written the equation. Now we will simplify it little bit. So we have the simplified equation at node V1. Here is 3 ampere minus 6 ampere is equal to I1, as I said that I1 we will represent it in terms of voltage. So I1 is equal to V1 divided by 5 plus I2 is equal to V1 minus V2 divided by 2. By taking LCM and solving little bit, we have this equation minus 3 ampere is equal to 7V1 minus 5V2 divided by 10. Now by multiplying 10 on the left side and rearranging, we have this final equation at node V1. Now on the other side, we have by applying KCL on node V2, I have written the current entering the node on the left side of the equation, that is 6 ampere plus I2 is equal to current leaving the node, that is I3 plus I4. The current entering the node on the left side of the equation, that is 6 ampere plus I2, and the current leaving the node on the right side of the circuit, that is I3 plus I4, that is leaving the node. Now as we have did earlier, the I3 and I4 will be represented in terms of voltages according to Ohm's law, as I3 is equal to V2 minus 0 divided by 4 and I4 is equal to V2 minus 0 divided by 3. As you can see that now we will simplify a little bit, as 6 ampere is equal to, by bringing I2 on the right side of the equation and putting their values by taking LCM, we have this equation 72 is equal to minus 61 plus 13 V2. Now by arranging it, we have this final equation of V2 node, non-reference node. After getting the equations of those two non-reference nodes, now we will there are three methods by which we can solve these two equations. The first one is by substitution method, the second one is by solving these two equations simultaneously, and the third one is by Cramer's rule. But here I will do it with by substitution method. So here we will extract the value of V1 from this first equation, that is V1 is equal to 5V2 minus 30 divided by 7, and put it in equation 2, which is 6V1 minus 13V2 plus 72 is equal to 0. Now by multiplying 6 with this whole factor and by taking LCM, we have this equation, and by simplifying step by step, we have the value of V2 is equal to 5.311 volt. Now by taking this value and putting it in this equation, we can extract the value of V1, that is here. V1 is equal to 5V2, that is the value of V2, minus 30 is divided by 7, and by simplifying we got the value of V1 is equal to minus 0.492 voltages. That is the whole method. By doing these, you can solve or analyze any circuit very simply and very easily.